Hello everyone, welcome back to the another video of the series Data Science using Python. In this video, we will learn about clustering. First of all, what is clustering? Clustering is a type of unsupervised machine learning technique used in data science to group similar data points into clusters or groups. Unlike supervised learning, clustering does not use labeled data and instead identifies patterns and structures in the data based on similarities and distances. What is K-means clustering? K-means clustering is simple and elegant algorithm to partition a data set into k distinct non-overlapping clusters. First, choose a k, randomly assign a number between 1 and k to each observation. This serves a initial cluster assignments. Second, iterate until cluster assignments stop changing. For each the cluster compute the cluster centroid. The kth cluster centroid is the vector of the p feature means for the observation in the kth cluster. B. Assign each observation to the cluster whose centroid is closest, where closest is defined as distance matrix. Since the results of the algorithm depends on the initial random assignment, it is good idea to repeat the algorithm for different random initialization to obtain the best overall results. Can use MSE to determine which cluster assignment is better. What are the steps for calculating k-mean? Here are some steps for calculating k-mean. K-mean clustering is a method. K-mean clustering is a method used to group data into k clusters based on similarity. Here is a concise breakdown of the steps. Step number one, choose the number of clusters. Use methods like the elbow method or analysis to determine the optimal key. Second, initialize centroids. Randomly select k initial centroid or use k-mean for better initialization. Third, assign points to nearest centroid. Calculate the distance from each data point to the centroid and assign each point to the closest centroid. Fourth, update centroid. Recalculate the centroid as the mean of all points in each cluster. Fifth, repeat. Reassign points and update centroids until the centroids stabilize or a set number of iterations is reached. Sixth number, output, final centroid and cluster assignments for each data point. Let's see with the code example. Here is the code. Import some of the libraries like import numpy as np, pandas as pd, met, matplotlib, skilllearn dataset, skilllearn cluster, skilllearn preprocessing. Step 1. Generate a sample dataset for clustering. For demonstration, we will use the macblobs function to create synthetic data with three clusters x, y, macblobs, and sample is equals to 300, center is equals to 3, centroid 0.60, random state is equals to 0. Convert the generated data to a data frame for easier visualization. Or it is an optional process. Step number 2. Visualize the data. Plot scatter, plot title, plot X label, plot Y label, plot show. Step number 3. Standardize the data. Optional but recommended for better performance. Scalar, standard scalar, X scaled, scalar.fit transform. Step number 4. Apply k-mean clustering. Fit the k-mean model to the scaled data. Step number 5. Check the cluster centroid and label, then print the k-mean label. Step number 6. Visualize the cluster. Scatter, title, X label, Y label, legend, so. Step number 7. Evaluate the clustering performance. Calculate the inertia to see how well the data points are clustered. And then print the k-mean inertia. So let's run this code and see the output. Here is the generated data for clustering. Here are the cluster centers and cluster label. K-mean clustering results are inertia is the sum of square distance to the closest cluster center, which is 84.015. So, thank you everyone. That's it for this video. We will meet in the another.